So this will be the last part of how to code good. Hopefully we'll go over like the rest of, I guess, the basic skills today. We'll be going over some more Git stuff, pull requests, merge conflicts and how to work through those, how to debug, some more general tips. Oh, also what testing is and like the different types of testing. So hopefully it'll be useful. I think it'll be very applicable for your projects in the next 2 weeks going forward. So we're gonna go over some proper Git branch usage. So the main things here is that for every new feature that you're making, or like if you're just doing something on your own, you should make a Git branch for it. You should never really be working on main, like ever, unless it's like a very specific change, like one line of code in like a config file or something like that. Because if you commit to main, you should have it like be tested and like it's bug free or like working at least. Hopefully bug free, but yeah. So just remember that that's like the golden rule with Git branch usage. You should be basically making a new branch every time that you're like working independently, trying to implement something. And like I guess for some like sometimes like for this, like if you have like a team of 2 people or just like it's yourself, like if it's yourself, then you can I guess work on main, like, and it's not like a big deal. But once you get like 2+ people, then you're just setting yourself up for merge conflicts when you work on the same branch and a lot of headaches. But ideally you should never be working on main. You should just be making a branch, like even if it's by yourself. So now we can go over some like vocab in this slide on the last bullet point. So once you're done with the feature and you're sure that works and everything else, and so you want to push it onto main and merge the 2 branches so that you can actually use the code. You can use a pull request and merge the branch to get your work on main. So this may result in like a merge conflict, and we'll go over this, and then we'll go over what a pull request is too. So what is a pull request, or PR as it's commonly called? It's basically just like it's some weird like computer science like vocab is like the reason why it's called pull. So like pushing, I don't know, but the whole like reason why it's named that is because like the owner of the branch, it's basically like a way to compare and see changes from one branch to another. So you can use this if one branch is ahead of the other in commits, as in like you've done more work on it, you can compare it to another branch and it'll push the difference in commits over. And so like you're requesting to like pull from one of the branches onto the other. And so when the branches conflict in the files, like it's like on the same line, like they have different things on different code, it results in merge conflicts. Like so they may like the 2 like pieces of like and files like may do the same exact thing. It's just that on a certain line, it'll have different content, and that's all a merge conflict is. And you're just resolving that. So for this lecture, I'll be doing everything in the GitHub UI because that's the way I do it. It's been brought to my attention. I didn't know this beforehand, but that most people use the terminal. So I will also be going over that, but I'm not as familiar with it. But we'll also go into like what a merge conflict is right now. So like I said, a merge conflict happens when there's a conflict between 2 files of code, usually on different branches when you're comparing. It really only happens like in one of 2 situations. One, when someone pushes code, like if you're both working on the same branch and then someone pushes code, someone else does, and then you push code that's conflicting with it to the same branch, and you haven't synced or pulled and haven't resolved those conflicts. So that's the first situation. I think that's the most like common one if you don't use branches by far. If you do use branches, I think they're a lot easier to deal with and they happen a lot less often because you're controlling when they do. And then, like I said, it only happens when you're creating pull requests and then resolving it. So we'll go through an example here in the GitHub UI, and then at the end, we'll have some terminal commands with examples of that. So first, like in GitHub for any repository, there's this tab called pull requests. This is how you actually view all of them. And just at the top bar here, as you can see, you can see like you can filter through like if they're open or closed, and all of them. So this is like if you see any like number here besides 0, it's just good practice to check because your teammates like maybe doing stuff, and just keep up to date with what's being done with pull requests if your teammates use like GitHub. So now let's say I want to merge like the complete branch of like workshop 10 onto the main branch of Tablet React. So first, I'll click this new pull request button. This is just below the top image. And so I'm going to choose a base branch. In this case, it'll be main. And then I'm comparing it to, in this case, like workshop 10 step 5. So the base branch is the one that the changes will be resulting on. And you're comparing the difference in commits. And that's why it's called compare. So once you create this, and depending on the branches that you have, it'll say like can automatically merge, which means that there's merge conflicts that you need to resolve. Or a lot of the time it'll say it can automatically merge, and that makes your life a lot easier. But it's not too much work either way, hopefully. Usually GitHub and like Git in general is really good at like resolving merge conflicts, unless you have like something that can't move. Like it's really good about like if you insert like a bunch of new lines in between something, it'll automatically do that. It's only when you have like two functions or just lines of code that are on top of each other, or you're changing like the content of one line specifically like across, and it's not white space or anything like that. So the next thing here that you'll see is like you can make like a title and then write a comment or description. You can also see like reviewers on this right side. You can use this feature. I mean, it isn't like too like necessary because it's a pretty small team, but and you can also like assign people to like resolve it. So this is good for like if you want to keep track of like who's doing what pull requests. This is like used in companies. So remember, like the GitHub is like a business tool, like for like, and that's how they make their money. So that's why all of this is here. So this is done markdown and everything else. So next step is to create a pull request. Once you have everything that like all the text information that you want. So now that like after you press this green button, in our case, we have conflicts that need to be resolved. In a lot of cases, like I said, like this check mark here at the top of can't automatically merge will be green, and you can just, it's basically just like a click I'm done. But we'll go through like the actual merge conflict. So you'll probably deal with this, but in the way that GitHub does it, you can see a bunch of stuff, but you can see all the 3 conflicting files on the left. And then for each file, you have to go through and resolve the conflicts. The conflicts are marked by these orange, I guess, like boxes. You can see on the lines of code. The left, like arrow things, or like carrots, like those, and then with the branch names to the right of them, those represent like below like W10 step 5, that represents the code that would be on that, like those lines for W10 step 5. And then everything above, like from the equal sign down, that's what's on main for that, for those lines of code. So here, I want to have main override that. So I'm going to just get rid of like W10 step 5. And you also need to get rid of like everything in like the main like line 2. The reason, like the way that GitHub at least like realizes that there's no conflict is when these like there's no orange boxes, and you basically have to get rid of like all of the main stuff and stuff that I added on. So here you can see like the snapbar.js, all the conflicts are resolved. So it just looks like a normal file now. Yeah, it does. So VS Code will have, so the question is like PyCharm has like very good functionality for resolving merge conflicts. Like, does VS Code have anything similar? VS Code does. When you push on VS Code, like with the source control, I think in the terminal it doesn't automatically go to this, but I could be wrong. But because it'll open up like a text editor in the terminal for you to resolve the merge conflict. But when you push on like source control on the left side, like what I was talking about in the part one, then and there's a merge conflict, you can resolve the merge conflicts there. And it's really helpful because you can actually see both. I can open up, I think usually 3 like windows, like split screen, and one of them will be the version on one branch, one of them will be the version on the other branch, and then the third one will be like the version on the new like merged branch. So then you can see and resolve it that way. Just make sure you know which one you're working on. And I think it's really helpful for that. Like yeah, VS Code is really good for Git stuff in general. So like I either use VS Code or the GitHub UI on the website. So now that we've resolved this conflict in navbar.js, we can resolve the rest. I won't like make you go through that, but make sure that like it's basically just deleting stuff that you don't want to keep from one of the branches, and then making sure that like it has and then making sure that the stuff that you want to like merge and keep from the other branch is like the end result. So I think merge conflicts are very like really scary at first, but like the word sounds really scary, but it's basically just deleting stuff that you don't want and keeping stuff that you want. So after you merge, and maybe like, and you probably like if you had a green check mark, like automatically merge, like this will basically be where it is. So you can commit merge. I think this is actually only, so I misspoke there, like this is actually only if you resolve merge conflicts, but after it, and then I think there might be like a different confirmation message for that, for if you like can automatically merge it. But basically after you merge, you'll have an option to close the pull request if you want. If you don't plan to do anything else with this, or like there's other reasons, like you should probably automatically already do this. But you also have the option of deleting the branch that you were comparing to. If like you're done with that branch, then you should do that probably, because you already have like a record of the commits on whatever branch you're using as a base. Make sure like one very common way to use pull requests beyond just like moving a feature or like updating your main branch is to actually compare, like let's say is to compare like another branch that's not main that you're working on a feature to main. So an example of like why you do that is if you start a feature and start working on something, let's say like 3 days, like 3 days before your team made like pushes another feature to main and merges it, and you're still working on that feature and you're still working on your own branch, and you want those changes, that's the like a pull request is really the only, like a merging is the only way to get those changes from main to onto your branch. So what you would do is in this instance, like I have W10 step 5 as the base, and then be comparing it to main, and so then you would be able to get all of those new changes and features. And so the reason like why this is relevant is that GitHub will ask you if you want to delete main after you do that. So don't do that. Just a note. And then here are the Git terminal commands that you can use instead of the VS Code. You would say your IDE, I guess, and then also the GitHub website. Like the first 2 should be done. This is when you have a branch that's remote already, so you already pushed it to the repository, and like you can check this, I guess, by like going on GitHub, and then like it'll say like the branch name if you search it. So the first 2 commands should be run like 1, 2. So you have to git checkout to make sure if you're not already on the branch you want to use this base. And then you can do the git merge with the branch name, and then you'll go through it on your terminal. There's like text editors there that you can resolve merge conflicts with, and however you do it. If you have a local only branch, so you haven't pushed your branch to remote yet to the repository, it's not like on GitHub. If you check that, you can use this. This command is git push set upstream origin. So to push your changes to the to remote, and also it also like merges it. So it's pretty useful. You can do like the setup screen. So yeah, that's the Git terminal command that I saw. Yeah, so I think that's everything for pull requests and merge requests. Does anyone have any questions? Okay, you can also go to the staff if you need any help. Now we're moving on to testing. This is basically just one slide explaining the different types of testing. So we'll put all these here. So, and then the main thing is like, if you don't test your code, it will eventually break. That's just like how, if you keep adding features, it will eventually break. Things will get deprecated. Like different library that you use, people will find vulnerabilities in your code. This isn't super like relevant for like the long-term like prospects of your project, but when, especially like in the next 2 weeks, if you're coding a lot, or just in general when you're coding a lot, there'll probably be lots of bugs if you're not testing, and it'll just make your life like really painful if you don't like actually test your code at all. So like we don't like, it's okay for your website to be buggy at the end of this, but realize that it will be buggy if you don't test. So the most basic form of testing, and like at least like whether as a UI is UI testing, you've probably all done this. We've all done this with like workshops and in class. You've probably all done it on your own project, and that's really just like running npm start, npm run hot loader, and then after you make a feature and like have it locally, and then just making sure that it works like the way that you think it should on your website. You're not really looking at any like backend data. You can if you want, like based on your console.logs, but UI testing itself is literally just like clicking around and making sure that it like doesn't obviously break. And then for like individual units of code, like functions or classes or stuff like that, those are called unit tests. And you have to actually write these in your code. And the tool I suggest is Jest. You can find it at that link on the bottom. And you have to basically write a bunch of test cases for every situation that you think that your code could encounter. So the way that like, and also all of this is all 031, 6031 content. So if you're more interested in that, then or taking the class, this is like one of the major topics. So the way that it's broken down is you should I guess identify like edge cases and then like regular cases like within your like the inputs for your functions. And so the way to make your test, like you can have it where like, let's say if you're expecting like a string for your function and you specify that in like the comments or doc string, then you can then you can test it using unit tests, but you're not supposed to. So basically every test should be like a good, like a well accepted like call to your function. And so like it doesn't break any like preconditions of your function. So like you don't have to make tests for like, oh, what if like someone like feeds this like a string into like a multiplication thing, you know? So that reduces the amount of tests that you have to write or should write. And then the other types, basically how they can interact with each other, making sure that the behavior stays the same. So integration tests, these are there to make sure that the behavior of individual components when they interact with each other is maintained. So like just making sure that the whole website works as like one entity and like the way that it should. And then when you're adding new features, you should add regression tests. And so that's just to make sure that the new features that you add on don't affect the behavior of old features. And then all of these together are called a testing suite. And once again, like the 031 reading is like amazing on testing if you're ever curious. So now I'm moving on to debugging. I think this will be really useful, especially for like people that are less experienced with debugging and like coding. So this like tweet is like really good. I really suggest you read your documentation for whatever library or like JavaScript or like the Mozilla docs. If you're ever like stuck or unclear on how to do something, then documentation will save you a lot of time debugging because they'll just tell you what you can and can't do. and it'll also help you with like seeing like where bugs might come from, because there might be like some quirks or like conditions of a function that you may not realize. So the first thing to ask, like if you know you have a bug, is where is your bug coming from? So like this is, for example, cat book, and I have a bug. You can see the log is all red, the browser console, and you probably experienced this situation many times. I know I have. So first, let's go through the flow of data in the application. So first we have, unless we're not using Mongo, we have MongoDB in the far back end, and that's our database with all the schemas and stuff like that. So the bug could be coming from there, but that's also a lot of times pretty unlikely, unless you said your schema is wrong, because those are relatively pretty simple logic-wise. The next step is the Node.js server in the back end. So bugs could be coming from there, but that's also, you probably haven't, unless you have like added a lot onto it, you can look there to see. But there's also the Express API in the next layer. That's a bit more complicated logic-wise, depending on how much API stuff you have. And then you have React and your source and all of the React components that you have. So these, like this backend, and the API back makes it the server side and backend, and then that's the client side and front end. So all of these could have bugs, but especially the React. So the first like 3 things that you should check, I would like personally, I just go straight for the browser console. You can do either of these like I guess like key commands like to open it, or you can right click and inspect, and then it'll open up like the side window on like Google Chrome or anything else. And so what you should be looking for is just looking at the errors and then reading them. Like make sure that you actually read the errors instead of just like guessing what the actual error is or bug is and trying to fix it, because these will, like if you don't read the error message, then you have really no clue. These are there for a reason to help you. The next thing I check personally is this npm run hotloader and see if there's any bugs there or anything from the front end. And if there's still nothing there that's like, or I know, like for example, like this error message in browser console, it shows that the error is in the back end. And if I know where that error is coming from, like maybe I sent a bad request to my API and that's why I'm getting that error. But generally, like I go front end to back end because like in the previous slide, a lot of the bugs are in the front end, what I found, because our backend logic isn't super complicated usually in this class for most projects. So for npm start too, it's usually like npm start errors are a lot simpler and easier to debug because it's usually like, oh, I got sent a string, but I was expecting a number or something like that. So the way to see these error messages and like kind of test, so in your browser console, whenever you do like console.log in your client folder is where this pops up. And then if you want to see it in the server code backend, you just have the console.log too, and it'll pop up in your npm start folder, or I mean terminal. And then also another like principle is fail fast. So this basically means that like you should have an error message as soon as possible and let whoever's using or like trying to debug your code like know as soon as possible, instead of just letting that like the bug propagate through. So this means using assert statements to make errors. And so errors may be scary to you, but like an error is much more helpful than something having no errors. And then just like, let's say like you have an error, like you have a bug in like your API, and then just having that propagate through to like the user website and having like super weird like behavior, like I don't know, like someone's name is like a number or something, and you expect it to be a string, and you don't know where the error is coming from. So you should be trying to assert, and like you can look up the JavaScript, like the MDN documentation and JavaScript documentation on assert and how to do that, and it'll really help, I think, in debugging and keep making your code bug free. So let's say we're in a situation where we did a huge mega commit, or just like made a lot of code, and we wrote 500 lines without even testing it. Okay, so now we open up localhost and it doesn't work. We can cry or cry. So like one thing with this, never write like 500 lines of code and then don't test it. Usually you want to debug every time. Like you have something like that can be tested. We'll go over that in a second. So I also want to include like Web.Lab debugging checklist. You can look through this, and this is like really what you should follow. So feel free to come back to these slides whenever, and then just like look at this if you're ever like, oh, I need help debugging or forgot. So basically, it just comes down to go through whatever is most likely to cause the bug to the least likely, and then Google any error messages if you find them, then ask your team for help or ask staff for help.
And comparing like Python or key workspace variables, like there are that any way that get result
Yeah, there is. So yeah, the question was like, can you basically debug through VS Code and like your IDE and see like statements with that, like I guess values of variables without like I guess printing them to the console? You can. I think you would have to do that in web development. When web dev, it's hard. Like in Python, like if you were in like any other language, like through VS Code, the code was running locally on your machine, it'd be a lot easier. But there, and like VS Code does have built-in breakpoints. Like if you hover over like a line of code in VS Code, you can see like that it's like a little red dot to the left of that. And basically that means whenever you run that piece of code, that the program execution will stop there and it'll have like any variable values to the left. I'm not really sure, to be honest. I've never tried to actually do that, like built in like terminal, like like IDE, like debugging with web dev. So I'm not sure how you would set that up, but there's probably a way to do it, whether that's through like Jest or something like that. So yeah, basically this is just what I said to you for like the last few minutes. So the main thing to remember with when you're coding and with debugging is when you have more lines of code to debug, there's more to debug, obviously. And it's also reduces like, I guess, the conservation of bugs, which would basically mean that like there's more bugs and it's hard because you have a lot more stuff to look at that you haven't tested. So you want to test your things piece by piece. It's also important to remember like our original rules of style. Keep functions short and modular. You want to test it whenever you can. So we can, and then we'll go through a few tips to like keep your debug loop short, which basically means like how many times, like the amount of time between when you make a change and test your app. So you're going to spend probably a lot of time debugging, which is completely normal. So any time optimization that you can make really helps. So we already have some tools in this class for this. We have React Hot Loader, like npm start, which we call React like no daemon. You may have seen that in your terminal, which really helps, like, so you don't have to re-render your website every time and it'll reset on any changes or file changes. Some more tips for like debugging is like, remember that just because everything works in the UI testing, like everything seems right, there may still be bugs in the backend, like with data. And this is why for each function or like page or whatever, whenever you're doing like more complex logic, that you should test like and assert all of your variables and the things that you're expecting to be true in that code. And it's also, I mean, also why testing is important, because the bugs may not always be visible and they add up over time without you knowing if you don't know about them. And then also, I really recommend like a really good form of testing is to like go on like, I guess like last time I was doing Web.Lab, I just did it with my high school friends. I just got on a call with them on Discord, and then like 10 of them like absolutely destroyed my website by just like randomly clicking around. So just get some people that like don't know about like tech or art like in Web.Lab, or just literally like anyone probably would work, and just get them to like randomly just click around and use it like actual user would. And because when you're creating a website, like you have an idea of how features should be used and how like people should go through your website. And if people don't like, and not everyone knows that obviously, because it's only you that knows how it should be done. So people will have different approaches to things, and usually you don't like, unless you like really think about like what could a user do to break this, people will just do things differently than you ever anticipated, and then they'll break it. And it's really good to find bugs. So if you have time, really recommend this. Another way that you can debug is called rubber-ducky debugging. If you don't know what that is, you can get an animate object or another person. But basically just like explaining your call, like your bug, and then going through like the logic and being like, okay, like this line does this, this line does this, this line does this. I know there's a bug somewhere in like this middle line, but I'm not sure why it is happening. And then you can just like literally just like say the code out loud and what you think it's doing. And you'll probably catch yourself. There's like, if there's a bug, it's usually because your code isn't doing what you think it is. And that's like pretty obvious, but like when you say it out loud, and then you'll probably catch yourself being like, oh, like this code does this, but I thought it did this. And just remember, one rule is like a stable, simple website beats a buggy, complex website. This is especially true for Web.Lab. Don't overexert yourself trying to make a bunch of new features when you don't need to. And then the overall summary for like how to code good in general. Git responsibly. You can go through like the first part 1 slide and also this to make sure that like, you have all the Git stuff down. Git logic is kind of complicated at first, and you may need to like think about like how you're going to like merge things or like ask all the questions. And then also like there's a lot of Git cheat sheets out there if you want to use the terminal. So just remember like it's just something that you need to get used to, and once you get used to it, it becomes a lot easier to use, and there's really a lot of advantages using Git. You want to limit hacky code and tech debt. I feel they just need lots of comments, develop with a tight or like low debug loop or like low time. Remember to fix your bugs, make sure that like everything's simple, all your functions are simple, all the coding style guidelines and stuff like that. And the main thing that I like want everyone to like walk away with is like communicate with your team. That's the most important part. I think none of this stuff is really as important as communicating with your team, because if you're on the same page with your team, then most like I think a lot of these problems get solved, and you know you're just working more effectively. Make sure that like you communicate, agree on like style guidelines, like what you're actually going to do and stuff like that. So there's more memes in this last slide from like, these are kind of old, but yeah, if you want to see them, here it is. But that's all for how to code good. And this is my last lecture. So I hopefully enjoy me having like teaching and being a lecturer. And congrats on getting to the last day of Web lectures. Next up is Web RTC. So thank you.